Hi there and welcome to Hyundai Power Products. So today a little bit of electrical diagnosis. So I'll show you the scenario. We're in the studio here so I can't run the machine, but I can go through the scenario. So the scenario is you have no output coming out of your machine. Okay, so you plug something in, the engine's running, you've got no power. Typically you would see zero coming up on here. Let's say you're seeing zero coming up on here. That could be another fault, but you could actually have power coming out. So let's start with the dead basics. Have we got the circuit breakers on? So if we're looking at 230, we need this end one on. 115, we need the other two. So let's just switch them all on. Next step, are we on 230? We switch it to 230, then we switch the breaker on. Have we now got power coming out? Yes, that's absolutely brilliant. You don't need to watch the rest of the video. If not, we'll take you through next steps. So our engine's running, we got zero on the clock, our breakers are on, our switch is in 230. Let's check the output. So I recommend you have a multimeter for this. You're going to need a multimeter several times during this diagnostics. I actually have an auto ranging multimeter so I can just plug it in and test. But what we would need to do is with the engine running, everything going, these top two pins basically probe the two terminals and let's see if we've got anything coming out. And obviously my engine isn't running and it's showing nothing coming out. It won't even find an auto range. But typically you would expect to see 230 volts. If that's the case, then it may be the appliance you're running that is faulty rather than the output of the generator. With that said, obviously this machine is perfectly good, but the engine is stopped. I would expect to see no volts coming out of here. So what could that be? Engine's running, everything's looking good. It could be several things. It could be a problem with a wire behind the control panel. It could be the circuit breaker not making connection. It could be the changeover switch not making connection. So the next step would be to remove this control panel. And obviously we're going to switch off and stop the engine when we do this. So first of all, we've got 4 bolts around the outside and then there's 2 cross-headed screws. So I'm going to undo the 4 bolts and then come back with a cross-headed screwdriver and undo the 4 screws. And I'll just pull the little bolts out, put them on top safe as I'm doing that. So I've undone the 4 bolts around the outside and I've undone the bottom one of these little screws. I'll just hold that, put all the bits and pieces on top. Obviously the machine isn't running and you'll see the control panel comes out with its back box. That was what the little screws were holding on. And I can pretty much, let's just place it in place, sit it there so it's not going to fall, and it's pretty sturdy by there. Okay, so we at some point are going to need to start the generator up. Now bear in mind, this is where all the hot electrics are. Obviously when it's all put together it's perfectly safe, but we're going to have live voltages here, but we're going to be checking. So it's a certain amount of care and knowledge is needed. But I'll explain, if you don't feel you want to take this on, then I'd probably recommend you get an electrician. But if you're a capable person and you show due diligence not to touch anything live, then this would be safe. So let me try and explain. The alternator puts out 2 115 voltages. So think of it as 2 separate alternators in sequence to each other. When we are using the 115 outlet from the machine, this changeover switch basically takes the 2 115s and puts them like that. So we've got, puts them like that. So we've got 115, but 2 windings joined together so that we'd have a positive and a negative. When we're in 230 mode, the changeover switch changes it to join the positive of the 115, this 115 negative joins in the middle, and then we've got negative, positive, 230 across the outside. So that's the purpose of the changeover switch. So what we're looking to do, now this would be with the engine running, it doesn't matter which position the switch is in. These terminals here, the black and red are one winding and the green and yellow are another winding. We would expect to be seeing 115 here, 110, 115, something like that, and 110, 115 across here. So we would start the generator up again, and as I say, making sure not to touch anything at all. And you can probe across with your multimeter set on AC voltage and just see if you were getting any voltage across these two. We'd expect to see around 115, you know, a voltage greater than 110, less than 120, shall we say. And again, we'd expect to see the same on these two. So yeah, probably around 110 volts, I would have thought is normal. So 110 there, maybe 115, 110 there, maybe 115. If those voltages are correct, we then switch the generator off, and we know that our problem lies not in the generator side, because these are the main 4 wires coming in. We know it lies within the control panel. So again, what we could do is look at the negative. So let's say we had voltage here, we had voltage coming out, we could detect voltage coming out. Let's have a look if we're getting voltage to the circuit breaker for the 230. Now the positive from the changeover switch comes in on this wire, which is normally the top of the panel, out on the bottom. So we need to see, we can probe here. If we just put the probe on there, that's 230 positive, or should be, because it's not passed through the switch yet. And if I go to any one of the negatives on here, so I'm going to go to the black one, check for voltage. If I get nothing, that pretty much tells me that there's a problem within this wire to the changeover switch. If I get 230 there, but I don't get 230 on this side, it suggests a problem with this switch here. So that tells me I need to replace this switch. Everything's happy. If we've got 230 here, but not to here, it's the switch, or the switch isn't switched on, obviously. So we've shown how to test the changeover switch to make sure that's throughputting, and the circuit breaker to make sure that's throughputting. Okay, so that is the scenario if the problem is that we've got voltage here, but not coming out of the socket underneath. So at this point, we need to be switched off again, and we can refit the control panel. That's the scenario that we haven't got 115 here, and we haven't got 115 here. We know that the problem lies deeper within the generator itself. So we've ascertained that the problem isn't within the control panel, it's deeper within the machine. Now there's a couple of scenarios here. 0 reading on here, that tells us it's in the machine. If it's got a low voltage on here, maybe 6 volts, something like that, that points us towards an AVR. It tells us the voltage is being produced, but the alternator isn't being excited. So it could be a problem with the AVR. So the next step is to go to the AVR, and that's around the back of the machine behind a panel. So the AVR lives behind this panel on the back. Now, as you can see on this panel, there's no circle here with slots in, so it means there's no fan on the lid. Now, should you have a DHY8000, this particular one's a 6, you may find, well, you will find an 8000 or an 8000T. You'll see there's circular slits in the back of here, which means it's got a fan attached to it. So when you remove the cover, you have to be careful that you don't drop it, because it'll rip the wires out of the fan. So just be very careful if that is the case. So I'm going to remove all of these bolts, bring you back. I'll bring you back when we get to the last bolt. I'm really going to leave this top one in, and I'd do the same if it had a fan in it, and that will allow me to grab a hold of the bottom and take the last bolt out. So last bolt, I can just make sure I've got the cover held securely by the bottom there. Again, not that important with this one. It wouldn't be the end of the world if I dropped it. Undo the last few turns of the bolt by hand and take the cover away. Now, if yours does have the fan in it, you'll find a connector plug in here. There will be a cable tie such as these around the connector plug. You can just cut it, disconnect the connector plug, and take this cover away. So the AVR is this horseshoe-shaped plastic unit here with the components on it. This is what we suspect to be wrong at present. So first thing is a visual. Does it look like it's burst? There's problems with it, scorch marks, that sort of thing. Does all the wiring look intact? Do all the plugs look like they're properly connected with their wires? Of course, the engine isn't running at this stage. Is everything connected properly? Are there any burns, anything like that? If there is, then we probably found the root of the problem. However, if there's nothing visual, it could still be the AVR that's gone. So what I'm going to do is, you'll see one plug just has 2 wires on it, a red and a black. These may vary, but there's one with 2 wires and one with 4 wires. On a 3-phase, it might be slightly different, but there'll always be one plug that has 2 wires. So I'll just cut the little cable tie off and disconnect the AVR. Now, this is the point where we can do a little magic trick. We can rule out a problem with the AVR. So what I typically do, I have got some small cables with a crocodile clip on the end. And what I do, and if I can bring you to it, my plan is to put 12 volts into here, straight from the battery of the generator itself, from the machine. Obviously, the 12 volt positive will go on the red wire, or the matching pin, and the negative will go on the matching pin to the black wire. So we have got the source of power here So what I have is two pieces of wire with female spades on the end that will just simply slip over these. So the black wire slips on this one, and we'll go down here onto this earth here, onto the body of the engine. That gives me the 12 volt negative. And again, the red one, as you'd expect, the red wire slips on this pin, and I connect it up straight onto this main battery terminal here with its crocodile clip. That then feeds 12 volts permanently from the generator's own battery, the starter battery, onto these pins which feed the brushes. So just a little description of what I'm doing. The AVR puts a DC voltage onto the brushes, which again powers up the rotor of the generator. Now the AVR varies the voltage depending on what it's seeing coming out. So that typically an AVR could be sort of anywhere from the 16 to 20 volt range. Let's say 18 volts it would be, and it adjusts itself up and down minimally to keep the output voltage consistent. What I'm going to do is rule out the AVR, putting 12 volts onto here, so I'm expecting when I do that and start the engine to get a low voltage reading on the clock. Probably somewhere over 100 volts, but nowhere near 200, maybe 140 volts, something like that, when I'm probing on the 230 outlet socket. So we'd see voltage come back, the generator's producing power, but not the correct power, because I'm not supplying the correct DC. That would then point us in the direction that the AVR is at fault. So that's a quick, simple change. And we do have a separate video, we'll put a link to it, on how to change your AVR. So, moving forward, scenario's getting a little worse. We tried that, we were putting 12 volts on, we ran the machine, and nothing was still coming out of the control panel. Still, you know, minimal voltage, 6, something like that, or 0 even. So that rules out the AVR. Well, it doesn't mean that it's broken, but it means that there's something else wrong as well. So I remove my clips, remove my wires, stop the engine, and we need to dig deeper in this end of the machine. Okay, so we're going to take this end off. It's not as bad as you might think to do this. It does take a little while, but it's not. I'll show you how to do it. So this particular machine has the exhaust coming out the top with this little cowling on, so I'll need to remove the cowling. Some of them have the exhaust coming directly out here, in which case we wouldn't need to remove the cowling. So I've already loosened the bolt, and I can pull the cowling off. Now there's 6 bolts around the outside. I've removed 5 of them just to speed things up. On the last one, I'll just place my forearm against it, the cover there to stop it dropping. It will only drop a short way. Let's just put my spanner down. I can bring the bottom out. Now you'll see a rubber pipe. I'll show you it closer in a minute. I can lift that up and pull that outer cover off. So this rubber pipe, remember when you're putting it back together, there's a hole in the bottom here. Just feed it through the hole as you lift it up and put it back on. Okay, so just be wary of that rubber pipe. So we need to move on now. There are a few things. We need to move a section of exhaust before we can take the big cover off. I'll take you to that next. So we're going to need to take this top section of exhaust off, and it's withheld by these 2 bolts which join the top and bottom sections together, and then to locate it within the frame there's 2 bolts up here. So I'll just loosen these off. So a 12mm socket, sometimes it's a 13, don't let that worry you, but this particular one happens to be a 12. So I'm just going to loosen the 2 bolts off. Okay, so then I need to, can I get in there? Yes, I can with my socket. Loosen off the nuts on this exhaust coupling here. Now this one's a little more tricky to get to. Just got it loosened off. So let me undo that bolt and drop the nut on the floor. I'll take the bolt out and I'll just make sure that one's nice and loose. Okay, I'm leaving that bolt in, you'll notice for now. And I'll come back up the top and remove the top 2 bolts that I loosened earlier. I'll remove them completely now. So they're quite long to give you room to screw them in. There we are, take those out of the way. And what you'll find is that this then, without catching in the insulation, a little bit of insulation there, you can just hinge it temporarily out of the way. So, as I said, with the upper exhaust, I've still left it on that 1 bolt, just hinged out of the way. Now gives me access to these 2 bolts. Okay, so again, remove these 2 bolts completely. Fairly straightforward. Now there is a gasket in here between the flanges. Just need to make sure that we don't lose that. You can see, can you see it? It's just dropped down there. So I'll remove the 2 bolts completely. There we are. And I'll keep hold of that gasket and put the 2 bolts back on the top. The outer cover here has bolts all around the outside, and it will now come out, but it's going to be held in position by this insulation foam and tape here. So what we're going to need to do is just around this edge, because this metal box or this rectangle is a separate piece to this outer cover, which is this bit here, 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 and here. So I'm going to undo the tape, and as you can see, it will re-stick afterwards. I can undo the tape and just bring it out, and that allows me, as you can see, now if I get this piece, just tease it away, and you can see I can take that piece of tape back there, just got the edge of that foam captive with that, this piece down here, this piece off here. I'm going to leave the tape behind inside the machine. Yeah, so just peel that back just a little bit, and that's going to give me the facility. I'm going to do the same there and the same on the bottom to be able to remove this end cover. So as you can see, I've just broken the seal between this outer cover and the inner chimney here, or inner air path, and just folded the bits of tape and the insulation back into there. So I can now hinge that back into there, just out of the way. Just put the gasket somewhere near. And now I can work my way around the outside of the cabinet, undoing all the outer bolts. So again, you don't want to see me undoing a whole load of bolts. I'll bring you back when I get to the last one. So again, got my elbow against the panel, take the last bolt out, a little bit more. This is the point where I usually drop it on the floor. We win this time. So I can take it by the handle, take the panel away. So obviously you can see now why I had to disconnect this area here. So we're going to work from best case scenario, the least problem, to worst case scenario, the biggest problem. Biggest problem being the alternator has failed. Best problem, it's an issue with the brushes. So as I said earlier on, these 2 wires here, the red always on the left and the black always on the right, is the power coming onto the brushes from the AVR. Now again, visual check first of all. Have we got any burning? Are these connectors on? Have we got a broken wire? Something like that. If not, okay, we've got to dig a little deeper. So remembering red on the left, black on the right. Always the case with these brushes. So I'm just going to be quite forceful and pull those brush wires off. So I'll just make sure that these wires aren't broken. Everything looks good. The connections and crimps look good. No burning or arcing been going on within the terminals. Happy days. So now we'll move on to the brushes themselves. So are the brushes worn out, or have the wires on the brushes broken? So you can see these little red insulators on the top, and they're stuck up maybe 6 mil above the level of the top of this plastic. That's because the brush has quite a bit of meat left on it, and it's pushed back from the slip rings up and given a good bit of slack in this wire. If you see this wire is very low, so it's gone down, that means the brush has worn away and pulled the wire down with it towards the slip rings, and then that's a good indicator that the brushes may be worn out. And again, you could just give these a little pull just to make sure that there's no broken wire in here. So of course there may be a broken wire in here. If you just give that a little lift, both sides, and it just slides out, then pretty much there's a broken wire, and it could be the issue is just the brushes. So with that said, I'm going to remove the brushes next. So the brushes are held in place by this single 8mm bolt and a lug on the other side. So I'll just undo that 8mm bolt. Take it out. So you can see the brush is pushed up because they are spring-loaded onto the rotor. I'll just put that bolt to one side and then lift the brushes up and out of the cavity. So as you can see in this case, there's plenty of meat left on the brushes. As you can see, I could tell that from the other side because the wires were up like this. Obviously, if the brush had worn down, we'd be right down the bottom, and there's a chance that that brush wasn't contacting the rotor. That could be why we have no output. So if your brushes have plenty of meat on them like this, you see, I can see these are stuck out 8 to 10 millimeters perhaps, but probably 8. If we're right up here somewhere, then there's a good chance that we need to replace the brushes, and that could be the reason why we've got no output. In this scenario, it isn't. These are perfectly fine. So we now need to go into testing the alternator itself. So I'm just going to cut this little cable tie here just so that you can see things better. Okay, I'm just going to push that out of the way. Take that out of the way, which is the earth. And that leaves me with the 4 wires we spoke about earlier up in the control panel, the yellow and green and the black and red. Okay, so again here, these 4 wires on this side are the 4 wires that are coming out of the windings of the alternator, and they're simply connected on these 4 poles. So yellow to yellow, green to green, red to red, and black to black. Okay, if your color coordination isn't like that, take a photo just to show where these wires were when you took them off. If the machine was working, it will have been correct. So just don't necessarily put them on. In many cases, the colors match. Sometimes they don't. It all depends on the batch of alternators themselves. So you'll see this white sealant on the end of each one of these threads and down the threads themselves. That's just to make sure that they stay tight. Now I'm just going to pick that out of the way. So it's not necessarily needed, but it does help should one of those nuts come loose and they can't come off the end. So what I'm going to do is remove these 4 wires off these terminals and then put the nuts back on. So again, I'm going to use my 8mm spanner for this. I'll start with the top one. I may have to wind the nut all the way because of that paste. No, it came out and it sticks in my socket because of the paste. I'll just take that black wire off from the top, and again I'll just place that nut back on again. Can I get it out of my socket? Probably, if I'm gentle. Yeah, it stayed there. So back on again. And I'm going to do that for all 4 wires. So we've disconnected all 4 wires in the same manner as I did the top one, and I'm also going to disconnect this green plug with these 2 wires. So this circuit here, the 2 wires that come out of the plug here, go straight up to the control panel. This is the auxiliary DC output. So this is what supplies the power, or it is an AC, it goes through a rectifier, but it's a low voltage AC output. And this basically goes to the control panel to supply the 12-volt output socket on the control panel. That plug's disconnected. Everything's disconnected other than the ground wire, which is absolutely fine. I can leave that there. So these terminals are all disconnected. The alternator's disconnected here. The only other thing is the 4 wires that go to the ABR are still connected to the ABR. I'm going to disconnect the ABR to take the ABR out of the equation when I test the alternator. Okay, so what I'm going to check for, first of all, is continuity up for each circuit. So we have 2 circuits here, 2 115 windings. Yellow and green is one circuit, red and black is another circuit. And they're completely independent and should be completely insulated from each other. So the red wire here goes into the alternator, round and round the wire goes round and round the windings for as many turns as it needs, and then comes back via the black wire. So that's the actual single winding. And again, the yellow and green will be exactly the same. So first thing I'm going to look for is continuity. So if I put my meter on, let's just do it. So on a beep test will do. I can see we've got a beep there. Let's just make sure, and I know this is a good machine, so I should get continuity. I have continuity. I should have the same on the bottom 2. Good. Okay. Now then, if I don't have continuity there, or I don't have continuity there, then we're in the dark hole of having to change the alternator, and that is what is fault. Okay, so that's step 1. Let's say we get continuity across those 2. We get it across those 2. We should not have continuity between the 2 sets of windings. So if I go between the green and the red, there should be nothing. And it's fairly obvious, we can't hear that beep. I go between those 2, nothing at all. Double check. Go across yellow to red perhaps, or maybe green to black. Absolutely nothing. Yeah. And again, yellow to black. Nothing at all. So continuity on those 2. Continuity on those 2. If I go between 2 windings, nothing. That's a good sign. In this case, well, I know this is a good alternator, but that's what you should be looking for. Now then, if I go resistance, let's just try, and actually take a reading. So if I go between red and black, I've got 0.4 ohms, very little. And if I go a reading on this winding, 0.3 ohms. Okay, that's the territory we're looking for. If you were seeing 20 ohms or 0, you would typically see a small resistance reading. 0.3 ohms is, and 0.4 ohms, 0.5. I mean, even up to 1 ohm, but you wouldn't expect 50 ohms or something like that. But that's highly unlikely. Normally the case is that you've got dead open circuit, so no connectivity. So what we're looking for is, on my meter here, if I look at two windings that shouldn't be connected, is OL, no beep, 0, complete ohms, greater than 200 ohms, over the limit, as it were. That pretty much means that we've got no connectivity. As you can imagine, if I touch my meter myself, my own body has, what have we got? 2.2 mega ohms, 2.1 mega ohms. Okay, so quite a lot of resistance, but it's not 0. So that's how we check those first of all. So if they're all coming in good, if they're coming in bad, we've got to change the alternator. If they're all coming in good, then we need to do the next check. So the next check is making sure that none of these windings are going to ground. So how we do that is I can basically, I'm on resistance. Again, let's just see. So I should be over limit when I touch this, complete insulation. Touch any one of these wires, and as you can see on my meter, over limit, absolutely nothing. So that's a good one. Okay. If, for instance, any of these wires were broken within the windings and were touching the chassis of the machine, that would put one of these connectors connected to ground, and that's when I'd start to get a resistance or, you know, a complete 0. Okay. So none of these must be touching ground. So that's another check we can do. Touching on the main body, touch all 4 terminals, absolutely nothing touching to ground. If anything is touching to ground, then again, we're in alternator change territory. So it's very difficult for me to show you, but our brushes, when they were in position, ran on what we call slip rings, 2 brass rings which are insulated from each other, and these run on those rings. So those rings are down in here. Now, I can physically see them if I stick my head over the top, but there's no way we'll get the camera in. So what I need to do is check resistance in ohms across these 2 rings. So it's going to be tricky for me. I can't really show you what I'm doing here because I won't be able to let you get in there. I normally use my long probes for this, and I've got some 90-degree ones as well. So let's see if I can get in there. So if I look at the meter, I'm on them now. I've got 50 ohms on my meter. That's around where we should be. I mean, if it's 48 to 58 ohms, something like that, that's what we should be looking for, is that resistance. Now, if I had 0, that means that the rotor is broken down. I should get a connection through there. It's another winding. So if I was over limit, that means that rotor is broken down and we need to replace the rotor. Can I get back on it? There we are, 50.3 ohms, 50.3. Anywhere between sort of 48 and 58 is normal. So that's a good rotor, but that's what I'd expect to see because it's a good alternator. Okay, so yeah, as I say, it's a little bit fiddly, but you can get in there, and you're looking at nominally 50 ohms or thereabouts. So with that said, if we get open circuit there, or OL, then that pretty much means that the rotor has a broken winding. If we get hundreds of ohms, which pretty much that probably means that we're not connected on there properly. But if you get a low resistance, sort of 10 ohms, 20 ohms, 25, 30, 35 ohms, that's when the rotor has broken down and we need to replace the rotor. So that is pretty much what we would check to say that the alternator's good. Another thing you can do is go off the windings. Let's see if I can just touch on the rotor again and just touch the rotor to earth, and you'd be expecting, and I'm on one of the slip rings there, and again my meter says, oh well, that means it's completely insulated from ground, that means it's good. So that means we haven't got a breakdown in the windings there to ground on the machine. Okay, so I've gone through the scenarios here of where we would see that the fault is on the alternator. I showed you what good readings should be and typically explained what bad readings should be. So if we've gone through all the previous procedures and we come down to here and then we find the bad readings down here, that says it's alternator change time. And that's a whole new scenario and a whole new video. But hopefully by going through these checks and working your way back through the wiring, we've got to a point where everything's good. One thing I haven't mentioned, if, for instance, we're getting, with the engine running, say we were getting all the correct readings down here, we could connect the ABR system back up, connect these wires back, connect the ABR system back up, not these wires, and then we can probe the voltage across these terminals with the engine running. But again, very dangerous. We've got rotating parts, we've got live electricity. We would be being very careful with our probe, probably a couple of wires with crocodile clips, so we're out of the way when we're testing it, but we would be looking for 110 across there, or 115, and a 115 across those. If we're getting it down there, and we're not getting it up at the control panel, this is another scenario, then we would suspect a break in these 4 wires somewhere between here and the control panel. That can be easy to rectify. We basically just replace the 4 wires that run from the alternator up to the back of the control panel, and that will probably fix our problem. But you can always put a test meter this end and the other end to make sure you're getting continuity again, the beep test. Red wire this end, red wire to the other end. Let's see if we've got continuity between here and the control panel, because it may be that the alternator's putting out voltage as it should, it's just not getting up to the top. Well, here we are, quite a long video, I'm afraid, but there was quite a lot to explain and a lot of procedures to go through. So I do hope you found this demonstration useful. For more information on this or any of our other products, visit www.hyundaipowerproducts.co.uk. I've been Adrian, and thank you for bearing with me.